Welcome to AP Podcast 14.5b, and this is a continuation on the weak acid solution chemistry, but now what we're going to do is we're going to talk about percent dissociation. And like all percent problems, you always have some large amount, and in this case it's the initial concentration, right, divided by into a small amount times 100. And the small amount is always going to be, in this case, the amount dissociated. And as you guys know, weak acids dissociate very little. So we're going to think of this number as being probably a small percentage. Now look at this bullet right here. For a weak acid, the percent dissociation increases as the acid becomes more dilute. Right? Now, in order for me to show that, we're going to do this problem right here where we're going to calculate the percent dissociation of a 1 molar and a 0.001 molar acetic acid. So let me go to another slide and let's start this problem. Alright, now I just changed up on the slide here. You'll notice that I changed it to 0.1 molar rather than 0.001 molar. So here we go, Ka equals, and I'm just going to make this quick, so I'm going to go x squared. Oh, what? No, pardon me. Let me do this. Let me write what the Ka is. 1.8 times 10 to the negative fifth molar. And, and that equals x squared on top, 1.00 molar minus x, right? Now when I work that out, I get a value of x to equal 4.2 times 10 to the minus third, okay? And so what kind of percent dissociation is that? Well, if I divided that by 100, divide it by 1 molar, times it by 100, I would get a percent dissociation of 0.042%. Now if I do the same thing with the other one, the other concentration, the lighter concentration, minus fifth equals x squared over 0.1 minus x. The x value in that case is 1.3 times 10 to the minus third. And I divide that by 0.1 and times 100, of course, and I get 1.3%. All right. So what we're noticing right here is that the percent dissociation for the lower concentration, it's more dissociated, right, rather than with a higher concentration. So if we look at our previous slide, right, so and that's what it says right here. For a weak percent dissociation, an increase in the acid, the percent dissociation increases as the acid becomes more dilute, and that's what we've just showed. And so this is kind of what we're looking at. As the concentration of the weak acid decreases, the H plus concentration decreases. That should make sense to us. A smaller molarity, a smaller concentration of H plus. However, and this is the key thing, but the percent dissociation increases. Now, about the only analogy I can think of is, let's say we have two police forces, and we have a police force of 100 people. I'll put 100 cops, right? And I've got another police force of 10 cops. All right. Now they each have to have 5 cops out on patrol. All right. No matter what. Well, for this police force, 5 out of 100, that's 5%, right? But for this one, 5 out of 10 is 50%. So if you could think of it this way, is the constant. If I'm trying to imagine that this is the stronger acid and this is the weaker acid, I'm not just doing a very good job of this. So I'm trying to show that even though the concentration of H has decreased, the percent dissociation has increased, right? So this one is 50%, even though it's a smaller amount. I don't know if that's a good analogy. I might have just confused half of you, and if a chemistry teacher that has a better grasp of that saw that, they might be laughing at me, but that's as good as you get. So let's move on to the next problem. All right, now I want to calculate the Ka from the percent dissociation. And remember, we've just got to be able to find the H plus concentration. So look at that first problem, and let's do it. All right, so here we go. I'm going to take the numbers that I was given, 8.1% equals the concentration of H plus, right, over the concentration of HA times 100. All right. So when I divide both things by 100, I get 0.081 equals the concentration of H plus, which is now my X value, right, over my original concentration, which was 0.1, and then I get an X value of 0.0081, right? So that's my value of X. Now they want us to solve for K, right? So I'm going to go K equals H plus A minus, right, over HA. Okay, now I can just plug some numbers in, right? I know that it dissociated by 0.0081, and so on the top it's 0.0081 squared, right? And then on the bottom it's 0.1 minus 0.0081, and that would give me a value of 0.0919. So then through the magic of math, I work that out and I get 7.1 times 10 to the minus fourth. And there you go. Well, hopefully that made sense. Now let's look at this second problem. 0.5 molar solution of trichloroacetic acid is the same pH as 0.004 molar HClO4 solution. Calculate the Ka for the trichloroacetic acid. Ooh, this sounds like a challenging problem. I'll tell you what. Pause the video, see if you can solve that, and then we'll see if you get what I get. Okay, so I'm going to walk you through this one because this is kind of a clever problem. Now, hopefully, you've noticed something. You've noticed that this is perchlorous acid, and this is hicalo, right? So this is one of our strong acids. So if that's a strong acid, and that's the molarity of the strong acid, what can we get from that? Hopefully you're thinking, well, gosh, I can get the H plus concentration, right? Because you know that this strong acid is going to completely dissociate in water, and that's going to give you that molarity. So if I take this number, 0.040, and I take the negative log of that, that's going to give me my H plus concentration. Okay? And so when I do that, wait a minute, back that up. That's not going to give me this is my H plus concentration. What am I saying? I don't even know what I'm saying. Yeah, I don't even need to take the negative log, right? They're just saying it has the same pH, which tells us it has the same concentration. So that tells me right there, sorry about that stumbling, guys. That tells me right there that I know the concentration of my H plus. So now what am I going to do with this piece of information? Because as you guys know, we've got to find Ka. So we know that Ka equals H plus, which I happen to know, right? And I'm just going to put the A minus there to save me some work, over the concentration of this guy. All right? So pause the video and go from there and see if you can figure it out. All right, so when you worked it out, hopefully you got 0.16 as being the K. And there's my work right there. And notice the one part right here, when I put the concentration of the HA, I had to subtract that 0.01 from it to get the right answer. So like always, if you have any questions, we'll talk about this in class tomorrow. And see you next time.